In this episode, we're joined by Hiten to explore large-scale Wi-Fi deployments. As a network engineer at the University of California, he brings real-world experience from high-density environments. He shares practical insights and best practices for designing and managing Wi-Fi at scale.
Can you please explain how big is your network?
We are spread over 2,000 acres with almost 400 buildings, which is quite a big 28,000 to 32,000 students, 5,080 access points and growing, about 8 wireless controllers, about 1,200 layer 2 switches, about 18 ADF layer 3 routers, which aggregate to our ISP called as Scenic. Lately, in order to save some money, we went through a laser way of bridging. So the data exchange for the two remote points is through the laser, and it is phenomenal, honestly. We are going above, I would say, touching around 5 gigs at a time.
So what are the most common complaints that you hear from users in your network?
So main complaint is, the network is slow, or wireless is slow. It's not working for me. We had a classic case, a professor who complained that it turns out he had 3 Chrome browser windows open with 70 tabs. You learn about the OSI model as 7-layer model, but as you work in this field, you realize there are 3 extra ghost layers on. One is the finance, the other is the politics, and the 10th is the users, right?
Hey everybody, welcome to Weekly Wi-Fi Wisdom podcast series where we talk everything about Wi-Fi and the tech that surrounds it. I'm your host Sainad. I'm WLAN QA engineer at Candela Technologies, and today we have our guest Hiten, and he started his career as systems integrator at Lockheed Martin, and then throughout his long career in networking, he worked at various roles. He worked as a project manager, and then he also worked as Cisco Academy instructor. And currently, he is working at University of California, where he is the technical lead and also a subject matter expert. He looks after and all the deployment and manages the network as well. So I'm grateful that he joined us today, and I'm really looking forward for all the practical insights that happen in deployments. So thank you for joining, Hiten. Thank you for giving us your time, and I'm really looking forward to interact with you in this session.
Yeah, thank you for having me on the show. Frankly, it was a big surprise for me. Thank you for the opportunity. Well, as per I would like to correct it, and I'm not the technical lead on the wireless. We do have a senior wireless engineer who works with us from past 3 years. His name is David Hunt. He was a TME at Cisco. So until that time, meaning it was mainly my focus and area till we didn't have a dedicated position. So, just clarifying that, when, like everybody, I started my educational background was in computer science with software development. Then I moved over to distributed computing. Then in Lockheed, I said, okay, fine. I was supporting a project where it involved engineers from Boeing and Lockheed. We were trying to make a constellation system for heat-seeking missiles, and that got me interested in RF. And at that time in 99, it was like, okay, if there is a problem behind the wall, you wait with the key by the closet and somebody comes and says, so it got me pretty infuriating. Oh, I can do this too. What's the big deal? And that time, CCNA was just come out and all that. And then the progression just happened from there. Regarding the Cisco Academy, I was one of the founding members for the community college over here called as San Jose City College. And there we started the CCNA, CCNP courses and all. And then, the dot-com bubble happened, and then it just, IT enrollment and interest just fell down through the roof. Okay, on with your question.
Right. Yeah. Thank you for the intro, Hiten. So let's get started. So as we are talking about large scale Wi-Fi networks, so let us start with understanding the scale of your network. So can you please explain how big is your network, and what are maybe in terms of access points and in terms of users? Please give us some idea on the scale of your network.
Just taking a brief moment for the people who might be unaware of the higher education system in US. Basically universities or the higher ed are, you can in general are classified into three categories. The state run universities in California, we call them as California State Universities, or they go by the acronym CSUs. There are private universities like Stanford, Santa Clara, and Harvard and Yale and Cornell and all that, which is a whole complete different. And the UCs are the research and grant based universities. So most of our funding comes from the grants, the professors' research grants, and a part of our funding comes from the state. So just to give you a perspective, the University of California is mainly comprised of 9 main campuses. You might have heard of UC Berkeley, UC San Diego, UC Los Angeles.
Yeah.
So, and we are UC Santa Cruz. So compared to them, we are a little bit lower in the hierarchy in terms of enrollment. But it is a prestigious research institution here in the city of Santa Cruz, which is 35 miles south of Santa Clara among the redwood forest. Established in 1965. We are spread over 2,000 acres with almost 400 buildings, which is quite a big, and it's surrounded by redwood trees and filled with deers and banana slugs. This is the only species available in Santa Cruz in all of world with no predators. It's like a snail-like feature. And we also have a good sizable population of mountain lions or cougars or leopards, as you know, in India. And we have about 28,000 to 32,000 students coming in on and off, grad, postdocs, including our extension, which is present in actually in Silicon Valley, called as UCSC extension. Plus, we also manage 3 wilderness ranches. One, where there is a lot of research being done in terms of ecosystem, the variety of flora and fauna, how they are affected and all. We also administer the network for the Mount Hamilton Observatory, which is up on the hills, and it is connected to other universities. There is a light scale presence even in Department of Energy, Lawrence Livermore. So our network is pretty spread out, and we have almost about 40,000 access ports. In terms of, I can give you about 5,080 access points and growing. About 8 wireless controllers of different sizes. Mainly our wireless is all Cisco, so it is wireless controllers 9880s, 40s, LF. About 1,200 layer 2 switches, and about 18 ADF layer 3 routers, which aggregate to our ISP called as Scenic. So every high school, public library, K through 12 universities, their ISP is probably Scenic, which is California Education Network, something I keep forgetting like that. and we run practically internet too, as well as which is a research grid by which faster access and faster data transmission, uploads and unloads are run. It is connected to a different research grid based on our routing policy and how that is at our egress and ingress points. We also have presence in AWS as well as in a remote data center and local data center. You know, I have lost the count of the fiber feet now and number of IoT devices. And to give you a perspective, I know it sounds strange, but we do have 13 SSIDs active, on our wireless network. And the students who live what you call as hostels, we call it as dorm or residential net, they have a separate SSID, but when they are in the main campus, they go through, you must have heard of the global SSID for secure wireless called as EduRoam. So, you know, they are, they can go to any campus around the world which participates in EduRoam and no need to get a sundry account or guest access. The validation or the authentication is done by the UCSC radius servers, which are in the RAM of the open room. Like they changed the name now. I think it's somebody else, but used to be Open Room Consortium, which used to manage it. And yeah, that's and couple of firewalls over here and there, campus and border and all that. So it's a pretty vast network. There are 7 of us in the team and another 7 technicians who keep this network growing and keeping under working conditions. We also have since being a research institution, we support the only genome cluster and a astrophysics cluster. We used to also host the cancer hub where, doctors and everybody can upload all the research or download the research about anything regarding the cancer. But the cancer hub is now moved to University of Illinois. So there are a couple of clusters we run. And we also have a vast raptor program, which does the birds of prey. So they need the wireless in those cages, as well as in the mammal tanks, because we are a coastal biology and a marine biology specialized university too. So we have to provide wireless access to gain the water temperature, the habits of the dolphins and seals. That was a pretty interesting project for us to submerge the APs inside the mammal tank down 30 feet deep and all.
Right. So I think the network is spread vast across many regions, as well as it's a very big network, as you said.
So we may have a use extension which is also in the valley, right? So we support that network too because they don't have a localized IT presence. So, uh, it all changed, so we had to take over their network and all that. So that's also pretty big. And then lately in the wilderness also we had to come up with a networking solution for the research professors over there. And we not only do the wireless networking and all that, in certain cases we have to make sure that there is power via solar and all that stuff. So that also comes into play as required.
Right. Yeah. Let us talk about the stages involved in deploying this networking. So initially, you may have a design phase where you come up with the design of how many access points or configuration rules and all that, and then you deploy. And after deploying, we also need to monitor the network as well. So I'd like to hear from you what are all the kind of stages that are involved in maintaining a very good network.
Okay. So one needs to appreciate that in higher ed, the wireless you can say wireless networks before 2020 BC, which is before Corona, and 2023, I would say, right? So before Corona, it was like a secondary access method. So it happened, okay, the Ethernet plate looks good over here. We are within the 100 feet. Let's stick a access point on the wall or the ceiling, and we have it as a secondary access method. Sorry about that. But then coming from Corona, when people realize that so the time when shelter in place was there, the projects were already in pipeline. So what can be done? Since the students weren't there, we started ramping the wireless. Mainly all the site surveys were done by, like guesswork or by contractors who just, figured out, okay, these are the access points we need, but nobody paid attention to that it is going to become a primary access method. And we slowly and steadily had started phasing out wired networking from our hostels or the residential network and moving to wireless. And the capacity you know was never taken into account, because at that time the contractors and all who did that survey, they did it all hallway, which coming back from Corona became a challenge. Right now, why do we have it in hallways stacked and all that and bleed over and all? So we had to spend a considerable time redesigning that wireless. Now, having said that, now we not all buildings were touched, so now you have to give further subcategorize that, okay, which buildings are you doing the wireless for? One, which are the legacy buildings, which were the historical buildings, then the architects come into play. You can't play around with the aesthetics. You have to get everybody to sign off that I'm not going to damage the historical value and all. Or you are doing for an upcoming building which is still being planned or will be constructed in a year or a two. So having said that, meaning we invested a lot. We went ahead and got ourselves a Kahu licenses for ourselves, and we decided that after coming from Corona, mainly we will do our own surveys and designs. So we start off with the predictive design. We try to get the blueprints from a project manager. So our whole department falls under the university ITS. So we work with the buildings and construction, or the engineering and construction department. They get us the drawings. We try and clean it up to make it palatable for our use. And in our survey at this time is Ekaha. That's the product we invested in. With Sidekick too, it has become a real good investment. We upload those designs. We come up with uh, the channel planning. And because of the senior wireless engineer, his name is David Hunt. His take is always plan for a tertiary coverage and in 20 megahertz channels. So that way, when the clients come in, they can be punted off to different APs. The load balancing can be achieved. And that is his reason. You always see in all the things that there is only primary and secondary coverage, but nobody thinks of the tertiary coverage. And because he holds a patent in the CapWeb, LWeb, multicast wireless roaming in in our clients, so it became very advantageous for us. I know many people shun the word roaming, but we in fact try to keep it not to have any sticky clients in it. So once we get our design in it, we plan in the predictive survey, we hand it off to the project manager. There is a lot of back and forth with the architecture, the construction people, because they are an outside company in regards to the things, and certain things they come up with, oh, this can't be done here. Because at the end of the day, you also have to understand that the electronic closets where the switches or to which the APs will aggregate eventually have to be under the 100 feet standard and all that, right? So sometimes plans change because of that. Many of the times because of the aesthetics, or they decided to put a fire sprinkler in the place where you had your AP going in. So all that, once that is all finalized up and the building comes up, and all the inspections are done wireless. When the fire inspection and OSHA and environmental health and safety, they release the building to us. We have the contractors come in, they do the conduits, they do uh, the cables, and obviously we give them the APs. So by this time we order the APs and all that because it has been signed off. The number of APs, the switches, and any number of SFPs which go in the switches. Because to give you a perspective, we run is a member, 3-stack member or a 2-stack member as needed to keep the redundancy, and we provide a LACP uplink to our routers. And the APs, as you know, right now, the 9136 and 9166 is what we use for indoor. We try to plan for a Wi-Fi 5 coverage, keeping Wi-Fi 6 in mind, and take it from there. And obviously we also make a room available for the IoT devices like the secure building management system, the security cameras, the doors, and anything that energy management system, which the groundskeeping needs it. And then one of us gets appointed who does the whole turnkey of the project, right from the APs to the configuration of switches, reserving the MAC addresses in the DHCP database so that correct IPs are handed out to the APs and all, and so they become light up. And once the building is up, uh, we go in and do another survey, because at that time we have understood who the population is going to be, what might be the use of it. If it is an academic building, then it becomes little convoluted, because we don't know exactly what type of other system they are running behind the scenes for their research work. So with the residential halls, it is straightforward. You know it real well that it is going to be students. They won't be doing much in regards to access and all, and application wise, because they would be using mainly everything of the cloud. Uh, and then once we find out that, and the building becomes populated, 3 months down the line, as a part of best practice, we have a student, we do employ student help who goes out and does another survey just to make sure that we got it right, or if tweaks are needed. Obviously, being a lean team and desperate team and such a huge campus, we don't have the luxury to go out every 6 months to do how the building is changed. Because, at the back of your mind, you are not doing a wireless networking, right? You are just changing an environment. You are changing the RF, which is already there. You are disrupting an environment, because by this time, when the building is occupied, you have people bringing in their plants, metal drawers, probably, uh, and then the complaints start. Hey, I'm not getting the signals record. Is it because all these attenuators were brought in? And then you have to explain it to them. And obviously, as you know, humans also are 80% water bags, so they are also an attenuator. So it takes a long process, because to make them understand that then an enterprise wireless is way different of an offering and presentation and engagement than the home wirelesses, where the walls are, you know.
Right. Right. So you mentioned that most of your gear is from Cisco. So how do you decide on the equipment that you are going to procure? So what are the key factors that influence this decision?
So the key factors, we work with our channel partners, and we also work with the vendor. We give them a set of requirement, because certain new buildings which are there, even though the cap which we call as capital projects, right, they had been already been making in takes 5-10 years. It you know just think of any government bureaucracy, right? It takes a village to come up together and make it, and then once everybody signs off, then based on our survey, we give them our requirements, the channel partners through which Cisco works, and we have a Cisco dedicated SLED team which, for the higher education, which every there is an account team with the SEs and all that. And we have meetings with them. We put in our requirement. We negotiate on the pricing based on, because we are a member of Scenic, there is a certain discount given. We find out the turnaround time, and they also have a say that, hey, whether the product is coming up to an end of life or whether we will have a mix and match. Now, as you know, before COVID, our most of our wireless access points which were there were 2700. But when we moved to the controller, the 9800, which is an iOS XE controller, sometime in 2023, it started having a certificate problem, and the only way we could make the 2700 APs work, which were mainly an LOS APs, right? We had to roll back the clock on the controller. Now that offset our monitoring thing, right? Because you are connected to an NTP server, and this was the worker. So the first part was to get rid of all the 2700 APs. So, and most of the bulk of the legacy till the were 2800s for us. And then we got in 9136 APs, which, as you know, is a tri-band BLE radios, but very expensive. So now the other one, which is of an inexpensive, is the 9166. Though we would like to go to the 91, the Wi-Fi 7, but it's not right now on our playbook because we need to make this work. And obviously, we also strive that one particular family of AP service is one part, no, the whole building. Don't try to do a mix and match, because sometimes it plays nice, sometimes it doesn't play nice. We try to keep it the same family in the same structure, even though it is the overall the same vendor. And obviously for the outdoor wireless, we have the 1562s and the 9124s. Lately, in order to save some money, we went through a laser way of bridging. So the data exchange for the two remote points is through the laser. Is called Trans-Celestial. It's from Singapore. Actually, it was a temporary setup till their building comes up, because the people needed to have a location and an office setup, no longer working from home. So instead of going through a Cisco radio for that or a Ubiquiti radio, we went through a laser link for it, which was a new experience for us.
How good is it working?
We had our challenge. Lately, we are not. It is a faster link. In fact, it became so interesting that even Cisco accounting wanted to interview the manufacturer. I mean, it's a Singapore-based company. I believe two Indian brothers run it. So, and it is working for us. Okay. And even with the weather and all, we experience extreme cold. We have never had still drop in the link. Initially, we did have a plane. They have a fantastic service. And even though due to the time difference, they took time and sat with us and the GPS, and they monitor and let us know. And it is phenomenal, honestly. We are going above the almost like, more than, I would say, around touching around 5 gigs at a time in the distance.
Yeah, that's pretty interesting to know. Yeah, it's fascinating. Yes. Yeah. Now, you mentioned that you clearly note down the MAC address of access point and maintain their IP. So documentation plays a very major role in large scale networks like this. So talk us about what kind of documentation.
So documentation wise, so we came up with the naming scheme, right? So wireless access points, right? how do we do it? So we decided that, we'll write in some code for our monitoring system to make sure how to sort and anchor the grab anchor points. So we start our access points, it sounds cliche now, with a WAP. Our switches go with SW something. So we put in a WAP building name dash, and we use hyphenated 3-digit number. So 00 means it will be in the basement or in the outside if it is. Floor number one, meaning what is floor number one in US is ground floor in India. So uh, so there is that difference. So and then we just keep on numbering. So floor number. So just in case, say a building. So since our campus is labeled as case 7 in the UC system, so it is WAP. Then the building number is 936. So WAP 7936 dash. If it is on the first floor, the first AP, then 101. And then, if keep on adding it to it gradually. So even we don't go by the room numbers or anything. And then when we move to the second floor, we go WAP 7936201301, 301, 401, and so on. And if there is an outdoor coverage like a quad or something which is needed, then we use the WAP 793600. And obviously in the location, we do put down the wall plate number, the MAC address, um, the last 12 characters of the MAC address and the jack plate number. So it becomes easier on the technicians to just go and take a look rather than, about unmount the WAP to see whether we got the MAC address right now. And then once we get the delivery of the APs, what we have done is we have carved out a separate IP address where we burn in these APs on a site. So a student helps us burn these APs, they label them, and they create this cut sheet, what you call, and give it to one of us, whoever is the assigned engineer. And we extract out the Ethernet MAC address from the spreadsheet, and do a bulk import into our DDI or the IPAM database, DNS database or DHS, and arrange for the IP addresses. So that way it gives, so when it goes out in the field, it grabs its own IP address, the classic AP join process. Meaning it would be a separate and podcast for you, for somebody to explain, but I'm not going in that. So once the AP comes on, it goes and polls, through UDP60 to the CAP web protocol, gets its own features, connects to the wireless controller. The one advantage we do a pre thing is because, when you stick in the AP and the wireless controller, the AP image is different than what the AP image available on the wireless controller is. The technician has to wait till the AP becomes completely provisioned, right? So this we have pre-provisioned it and sent it out in the field. So they just stick it in. Mainly it is the contractors who just mount the APs physically. When then our employees or the technicians, they go in and connect it or patch it to the switch port, and they take a look once all the cabling needs is done, and they do a preliminary survey whether the AP was didn't die in the field or didn't get stuck while upgrading or booting or coming back in the field. So that saves us time. So you can sometimes appreciate 500 APs coming on one line at a time, or as low as 50 APs. So that is how we do it, and it's a process, meaning we have fine tuned it over the years. So it has now become secondary. Once we have all this documentation, then this cut sheet is uploaded into another database. So come tomorrow, when somebody reports a problem or our monitoring software says this AP is dead, so accessing, we can find out the grid, the switch port, the jack number, and everything, because the AP name and the IP address shows up on the monitoring. So we back reference it, and we exactly nail down to the switch port and the access port in the closet on which floor, which building it is connected to. we create the trouble ticket, give it to the technician, and then the remedy is whether to replace the AP. Then obviously, when they go out with the new AP, they call us with the MAC address. So we just do a replace in the DDI rather than going through the whole circle. Or if the AP just needs some kind of a bounce or a troubleshooting, they exactly know which switch port to go to, because many of the times I mean, people would just go to the closet rather than take the ladder and go. And some of the APs being in the residential hall comes into, and if students are occupying and they are in there, then there is certain kind of, different permissions are needed, because obviously, they are students. We can't go barging in the room like we can go in an professor's office or a secretary's office or a dean's office and say, hey, I need to look at it. With the student rooms, it becomes a little difficult for us, and we need to have an escort and a special permission and different set of keys. Obviously, the ramifications are there, so that makes, so documentation is of very much importance. And this helps us also to come up with the life cycle when the end of life is given, whether rip and replace needed is needed or salt and pepper approach is needed. We come to know of it too. And
Right.
I forgot it. So obviously all these APs then got put on the heat maps which we have in the ECHO survey, and we maintain a cache copy in our Google Drive and upload it to the AI Pro, which is now the online cloud of ECHO. And we also use Catalyst Center, which was used to be called as DNAC earlier. We upload all those heat maps to the Catalyst Center. So exactly, and we have carved out the whole campus into hierarchy in our Catalyst Center. So exactly which building, which floor, and what APs are available, and where in that floor map where that AP would be mounted, you can come to know. And that way we can do a predictive design and everything from the Catalyst Center too, because ECHO has that built-in support for the Catalyst Center. So that's the main thing. So first thing is to go there and find out how that AP is behaving too once it shows up as a fault on our monitoring software.
Right. You mentioned that you also closely look at the issues that you get. So, what are the most common complaints that you hear from users in your network?
So, as you know, in the IT world, who works as engineers, right? So there is this, obviously everything you go is with OSI model, right? You learn about the OSI model as 7-layer model, but as you work in this field, you realize there are 3 extra ghost layers on the top of 7 layers. One is the finance, the other is the politics, and the 10th is the users, right? So main complaint is, oh, the network is slow, or wireless is slow. It's not working for me. And it is a pretty loaded question, right? So one has to first, based on the documentation, find out what's going on. We do have a 3-tier system. So obviously there is a campus student help, a mini help desk, which helps for the faculty and the students. There is also a residential IT, which caters to all the students who live in the dorms and the hostels and all that. So they are the first level of support. And within us, we have is another person who does the triage of the tickets when these two organizations fail, and it gets piped towards us. And the question comes is, okay, then we find out what is going on in terms of, we log into the Catalyst Center to find out. We have the client's username, MAC address, and as you know, now everybody carries, every webinar you attend, they say survey for 4.5 devices per person. I would say do it 6, because there is iPad, Apple Watch, phones, this, that, and then suddenly that rabbit AI and something or the other is always going on, right? I know it is too much liberal thinking, but 4.5 seems, I think, is the number which is less. So you find out what exactly they were doing at that time. I mean, many of the times it is hard to give a personalized approach, right? So based on all the leading questions, what you ask them, and sometimes the truth is modified in a way that, oh, I didn't do anything. We had a classic case, a professor who complained that, the wireless access system is outside his office, maybe because it was an old time survey, so they did it in the hallway. He keeps his door open, but he cannot get the signal strong enough. And it was a constant complaint. The next thing, okay, one fine day, I picked up my laptop and I said, let me go take a look. Usually we don't do that, but the manager, I see this permission that it seems to be a chronic complaint. Today is a slow day. Let me just walk over it. This will help me. You give them that feeling that they are not orphaned either. So it turns out he had 3 Chrome browser windows open with 70 tabs. Obviously, Chrome browser, right? I know it is Google, but that is a memory hog. And your machine slows down, right?
Right.
So, and then what can you say, right? Hey, don't, try closing some windows, try closing some tabs which you don't need, and then it will work. And then other people, in certain cases, there were environmental factors. We had the classic case you have heard that at 12:30 p.m. they are warming their food in and they are trying to watch Netflix or something social media at lunchtime, warming the food in microwave, and suddenly the signal goes bust. So that are kind of the complaints. Other complaints in terms of, mainly, okay, we start with layer 1. Okay, that looks good. We start with layer 2, layer 3. You got an IP address. We don't have a captive portal if you are a registered student or something. And probably it is a part. Did you get an IP address? Did you get this? And you go from there. You go through the 10 steps process, right? That, okay, me always any troubleshooting in network starts with layer 1, right? So once you are going up the stack, you keep going and then find out where the showstopper is and then help them, provision it. I mean, one classic case, we did have a problem with the coverage because of, and after and it is not always we do it, but the insertion of an AP helped elevate the experience real good because the environment improved very well. So that is very rare. Certain cases when we go and now because of we trained some of our student helps to go out with the sidekick, do a survey. So we find out the exact environment right now. And if an AP needs to be moved or added, we will go that route too. But most of the problems are like, okay, password or, going through the SSID or messing up in that I got into the wrong SSID. Another one classic case was one student help wanted to use his 2014 Chromebook just to read his emails. And he was very adamant, and there was nothing we can do to convince him. So we had to do a MAC bypass for him. Just get his MAC address and, bypass him and let him access on the network that way.
Right. Now, let's talk about where you have lots of users, the dense environments. For example, be it large conference rooms or hallways where there are lots of people. So, how do you come up with such high capacity uh, uh, requirements, and how do you handle such capacity spikes?
So again, we do it with the keeping the capacity in the mind. So if a classroom lecture hall, you would say about like 500 students. Now it is 500 students. You can count easily 3 devices per human, plus the professor, and then there is multimedia equipment to, to broadcast the lectures and all. And many of the times these students, they take the exam, so they have is the wireless pen, which they, it is like a survey like, and they just click and they do it. So in order for the classroom, we what we do is we go and find out that, okay, what are me the first pay attention is about, like in a 500 seat or a theater, meaning the general rule is we do our echo survey again, predictive and all. We also find out that normally experience has thought out about like 8 APs or something which work out for us. Okay. And there's one I wanted to say. Then we do is a higher density channel planning, in terms of, like, adjacent cells should be at least 2 channels apart, like, 3652 44, 3652 4. Separate adjacent channels at least by one cell, like 44 116, the honeycomb structure. If you can translate the 2.4 into the 5 gig, eh, we do have the luxury of the unity with larger spectrum in the 5 gig and 6 gig space compared to the world. We also make use of the DFS channels because our main campus is far from the coast. I mean, our marine biology, we don't do the DFS channels. We have removed it from our, planning also. And then we use 20 megahertz channels with reduced power. Okay. Uh, and what we do is we tried, as soon as you enter the hallway and you associate with the AP right close to the entrance, but as you move towards the class in front of the rows, we try to have you, because we cover for the tertiary coverage, right? So it automatically gives you a neighbor report and pushes you, this AP is the correct AP for you to associate. And that's the way. And as I said, keeping the transmission power low helps people to de-associate from the entrance APs and move to the further room. And many of these classrooms, we also had to, meaning, I know it is a discouraged practice, but we had to, some APs are like mounted on the wall, but we have to tilt it like at 42 degrees angles, and use directional antennas so that the signals are properly dispersed. There is a good RR, and we take it from there. And each classroom is a different classroom for us, because obviously, as I said, the building materials, how much glass is around, how much wood is around, that also helps structure the environment and influence our design a lot.
Right. So you mentioned that you estimate for about 4.5 devices per user, right? So there are lots of client devices that each user can carry, and it, it's of wide variety, right? So we cannot predict what kind of client devices they get into the campus, and there are IoT clients. And so what are the major problems that you see with client devices, be it sticky client or any other behaviors that you see wrong with the
So
client
the
specific
challenge
issues?
comes in, students, you can appreciate, right, that they will bring anything their parents can buy, afford. Obviously, you know, uh, now everything is electronic, and 80% of the traffic is in the cloud and 20 is local. When the olden days was 80% was LAN and 20 was WAN, right? Now everything is out in the cloud. So you have to appreciate that, as a parent who has a student coming into the college, they will buy them the latest and greatest. So you don't have any control on it. But at least, okay, fine. As far as it confirms to 802.11a, AC lately, or B, we should be good. it is where the staff and faculty make a big problem. When the staff and other organization unit, okay, like the IoT devices, right? So these people, okay, I want to monitor my sprinklers. I want to monitor the cameras on the door. How and whatever they find the most inexpensive, like I said, the eighth layer of OSI model, right? That affects that decision. So they don't bring us into the picture. Obviously, we can't afford to change 1200 network gear to make yours to work. And our access ports are 5 gig and these work at 100 megs, right? So we try our best to sit with them, explain it to them. Many of the cases we had to buy a mini hub or something just so that their devices can aggregate to us, because they couldn't do 1 gig of speeds inside their controller system or the embedded controller. And if they have a wireless system, then we have to be very, very right. In one of your episodes, it was a great episode. I learned of Bluetooth a lot. How the spectrum, I forget the gentleman's name. I think he was from Candela himself. I think yeah, Swansea. Great story of how the Bluetooth works, right? And these have a habit, so we try to, if Bluetooth or or those lower capable devices, we try to keep them on 2.4. We have created a devices only SSID, by which on the portal,
Right.
the person who owns those devices can go and register the MAC addresses, so we are not every time called for it, or a divisional liaison or the local IT person can help them register their devices. And that's how we get them to the network, because we still have to keep the security in mind. Whereas for the client device, we do a certificate based 822.1x versus making them enter user and password all the time. And that's how we do it. And many of the times, sometimes you have to bite the bullet and say, hey, no, it's not going to work. You either, for the $2 IoT device made in China, I'm not changing my $1 million network. And that's a call at the 9th layer and the 10th layer of the OSI model. We gave everything, we tried everything, we had tried to be accommodative, but at the once in a while, you have to call the hard shot.
Right. Yeah. So now let us move on to network monitoring. So which tools or platforms do you rely to carefully monitor your network and identify issues proactively?
So, as I said, our main is Catalyst Center for the APs, because we are now transitioning our L2L, I mean, mainly L2, L3 was always Cisco, the L2 gear to Cisco also. So, we are putting all the switches based on the licenses. We also use a ping monitoring software called as AKIPS from Australia, which runs like at the fastest speed, and all the devices are registered through SNMP on that devices, and it goes through IPv4, pings them at a regular interval, and if it doesn't answer in 60 milliseconds or something like that, it throws up a flag. Then we also have smoke ping, which is an openware, which helps us monitor our links. And obviously, in the cloud and all the step by step, because the BGP looking glass is no longer available, we have deployed the Thousand Eyes agents along the way, which helps us find out. Obviously, the system engineering, I forget what they use, but we also have a presence in there in terms of our devices. So whether the VPCs are running up and all that, and Route 51 in Amazon is going down or not, that also helps us. And obviously, we are always in constant touch, and notifications are being sent out by our ISP, the Scenic. If there is an outage on their end, they let us know. So these are some of the softwares we are there we use. And obviously, as I said, the budget plays a big role into this. We used to have 7 signal monitoring for wireless at one time, but the prices increase. I mean, now many one has to also understand, early the university models believed in the capex of the product rather than the opex of the product. So they feel, okay, we buy and it is ours. But now everybody wants is a subscription, right? So it becomes little bit hard for us to do it. And the another tool which nobody uses, but I use it, and my counterpart David Hunt, he sometimes, many of the times, if it needed, we use another multi-join OS, Secure W2, who is the company. They have we use their onboarding for the clients, laptops, the Chromebooks, the iPhones, Android, so that way it is less of user intervention. So if you have a cloud account in there, usually it is mainly all the 7 guys who of us only have it. We can exactly know which MAC address and all also has had a hard time profiling where in the onboarding it got stuck and all, how the profiles were generated. So it is not one tool. You have to take a global view. Not everybody gives you, because you have to see where the problem lies too. Right?
Right, absolutely. And you touched upon security. So, did you face any attacks on your network? And if yes, what are the most common kind of threats that you see, and how did you mitigate around those
So
attacks?
in a way, we we do have campus firewalls, and we also have is ICE, which is our MDM also in a way. May the other way, for the students who live in the residential network, they when they are within the campus or within the the logical boundary of the network, they use the regular class B addresses, but going out it we use is a carrier grade net in the 100.64 space. So that helps us, which goes through the stateful firewall system. So that helps us prevent the attack. Most of our attacks which we have experienced, meaning we have a separate infosec team which makes the policy, is mainly of the kind of DDoS attacks, denial of service attacks. Those have been there. Constant port scanning and all keeps on going at the outer end of our network. Certain handoff is also done by Scenic. So all those, they all work in concert to try and help us prevent some of the attacks. But once in a while, if a vulnerability is being exposed from inside, that becomes a little tough. But touch wood, since last 10-15 years, we haven't experienced that kind of an attack much. And obviously we keep on the news, we keep all the we patch up our network, all the software on a regular basis, or when the vendor announces the vulnerability, or the when the bulletin comes up, the CVE, I think that's what the acronym is published, or the NIST, right? That's the organization which publishes. We try and patch it up, and before it goes public, obviously a patch is released for us, or a workaround is released. So we take care of all that.
Right. So, uh, you mentioned about the old legacy devices that were there on the network previously, which were unable to connect. But how often do you refresh your main network gear, and what drives the refresh decisions? I mean, why do you upgrade? Is it for better optimization, or is it for the newer Wi-Fi standards that are coming up? So, uh, talk
So
about
the
it really.
refresh cycle now, in my opinion, and lately what we have been experiencing, is 5 to 7 years. So our standard model was gig to the desktop. Um 10 gigs to the layer 2 or 3 or the distribution layer. I'm sorry I'm using all the Cisco terminologies of core, access, and distribution, but I am pretty sure your audience can relate to it. So we used to do 10 gigs to that and then 40 gigs to our L3 devices. But because you see applications have become savvy, time lapse, latency needs to be cut down. So we decided, all our layer 2/layer 3 to our layer 3 and above will be all be over a fiber links. And we have upgraded to 100 gig. Our outgoing egress to our scenic is on 100 gig optical network at this time, soon to be still revamped. Uh, New buildings we lays Cat 6A cabling because our access port switch is the ones which we are deploying. The access port is operating maximum at 5 gigs. Obviously, the APs you obviously know they are theoretically 10 gigs and all they are saying, even though you don't achieve it, but it's still there, bonding. So keeping that in mind, and it is human nature to bring in latest and greatest, right? So we have to cater in that. But for the legacy device also, then we rely more. Okay, it's mainly plug and play, and let's auto negotiate. Will take care of it type of stuff. But you know, uh, it is a hard decision to come to know that whom are we serving, and we have to obviously move with time because mainly everything now has become, again, to beat the dead horse. It's like I need more. 80% of my traffic is all external, so I better make sure that I provide the better equipment. And in the olden days, vendors used to do a port by port trade off, so it became easier. But now, anything, if it lasts you more than 7 years, you got more than your money's worth. I personally feel. In 5 to 7 years is a refresh cycle, and we stagger it. It is like, to give you an analogy, it's like painting the Golden Gate Bridge in San Francisco. January 1st, they start from the south end and they reach the north end across the Pacific Ocean by 31st December, and they again start it. So it is like, okay, by the time I finished my phase A and I'm getting down to phase D, I have to again restart my phase A. So that is something, it's how we take the approach. And for such a large university, we have to do it. I mean, there is no choice.
Yeah. Yes. And now, during upgrades or maintenance, so how do you ensure that users are well informed about the maintenance
Okay,
that's about to happen?
two big questions. So first of all, during the school time, right, when the quarter, we are on a quarter system, so 12 weeks quarter, 3 main quarters, right? So especially the 11th week and 12th week, it's completely hands off unless the gear is burning up, smoke is coming up, then touch it because it's time of final exams and grades. So don't touch it. Then during the school year, if it is detrimental, then we have, so if it is the campus gear and not the residential gear, we have a blanket maintenance window from 5 a.m. to 7 a.m. So any patchwork or anything we need which is just ubiquitous to them, and we make use of that window. We notify them in advance that we are going to do. For the whole campus wide, our CRM is service now, and we issue a change management, so nobody becomes a cowboy to do anything. So the change management, depending upon the severity, goes through a process of vetting and approval. And once the person, depending whether it is a department which is going to be impacted, a campus is going to be impacted, or a division is going to be impacted, or more, or It's a global impact. Based on that, the approvals are sought. We have to give our plan whether the patch we are doing is going to be real time, whether it has been tested or not. If not tested, then what is our contingency of rollback? How much time? All this we have to put it down, and then it goes for a vetting process. So depending on the severity, or we say it is we have to do it, then within 2 hours we get our approval, and we obviously will do it at 3 a.m. because obviously the students, they work till 2 a.m., right? Most of the network traffic, if you keep monitoring, then it's until 2 a.m. The silent period on our network is from 2 a.m. to 4 a.m. in a way. And
Right.
so usually at that time, whoever is the engineer assigned to it will take care of it. Many of the times, if we stage it and keep it because of the boot file space on the switches and the gears and on the controller and all being there. So we as I was saying, and we keep a reload time and the boot flash time that make this active as of this time. This is, we can take this liberty if we have tested it. If it is not tested, we would supervise the upgrade, do a manual patch, and be ready to roll back. Like when this interest had come from a podcast, I mentioned to you I'm in the middle of a forklift upgrade. Two of my, and it was like forklift upgrade is rip out the old gear,
Yeah.
which was a 6880 router, which was serving about 700 students and, three departments and few colleges. So I had to rip that out and replace it with a new router. But the problem is, till my new router is not accessible and is not communicating, I couldn't. So in my test, I forgot to, and I admitted lesson learned that I didn't put in an IPv6 area OSPF statement, and it was working negotiating at 4, but it is not working at IPv6, and I just couldn't figure it out because you are working at 3 a.m. in the morning and you are trying to cut through, because on the other side there is a technician who is physically moving the circuits as you keep giving them the go ahead. So so two times the upgrade failed, and then I set and vetted out the configs again, got another set of eyes because you sometimes become blind. No, 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 it's right and all. So all that things, when the change management is approved, that is the best way to document it. So come when the change management window is over and the campus has started at 8 a.m. or 7 a.m., classes has stayed, somebody comes up and says, hey, this is not working or that is not working. We exactly know, because obviously the first question is, when did you notice this change? What made you find that this is not working? So we ourselves knew we made these changes. Many of the cases like the Apple laptops, and sometimes you make them reboot because they cling to their own old given IP addresses. They cling to the AP which they love, from which they got the positive response, wouldn't move even if you moved or did a L2 or a layer 2 or a layer 3 ROM. So in those cases we had, one or two cases like that do show up. There is always a straggler, and that helps us. So I think the change management window is the best way. We notify it, the campus knows it, the local IT people know it, the other people also know it, and it helps them back, just in case if there are 2 a.m. backups running in the data center and the backup fails, they know that, right? That, hey, why did the backup fail? Because that part of the network was reload. Those devices catering to those backup servers might have reloaded because of an applied patch and all.
Yes. So, from all your experience, from all your networking experience in maintaining and deploying devices, so what is your biggest challenge that you would say?
The biggest challenge is, it's like this, don't get afraid of the problem. Used to be, people, because uh, my classic case, let me give you an example. Before I worked at University of California, I was up at University of Nevada, Reno after the dot-com bubble, They had an exhaustive interview. I gave the interview and all that. So obviously there is always that question, right? Do you have any questions for us? And this used to always bother me, right? So I asked this question, and this will give you the perspective of the answer you are trying to find out from me. A professor calls up and says, I am friends with the president of the university or the chancellor of the university, and I'm having this problem. So, do I drop everything and rush there, or how do I answer? And over there, the manager whom I worked for, great mentor. I learned all fiber technology from him. So he said, very calmly, that explain to them that you have understood their problem. It will take some time to research, and you are doing your best to help them out. And if they start yelling at you, then there are two ways. You can either you punt them in my direction, or you can also say that the same people who signs your paycheck signs my paycheck. you know you are we are going from there. So the first thing is, don't get afraid of the person who is calling you. Understand the problem. We have the answers, but nobody questions the correct way, right? It may it's like going. We had this discussion. You go to a doctor. I'm not feeling well. How does it start? The doctor says, "Okay, what did you eat? How did you do? What made you change?" Right? Those are the leading questions you ask to gain a better picture. Now, as I explained it to you, we do have three-tier system, right? So efficient history and note taking, if it is on the ticket, then you take time to read it. Don't become trigger happy to solve the problem, right? First, understand the problem. I go one step. I just call up the user because their phone number is mentioned or something. And I just tell them, tell me in your own words, what exactly is your problem? Let us see. Because now that you have come to me, I'm like a layer 3, layer 4 support in your hierarchy of your support. So let us see what is the problem. And nowadays, personally, because of these agentic browsers, life has become very easy. I personally think. So if you work on your prompts, you mainly find the problem. And if you, I don't know if you are, because we are a Cisco shop, we have our Cisco CCO user login and all that. They have a AI canvas in it. So many of the times you plug in the correct issue in there, it tells you what to do it. Because what they have done is they have created a whole repository of the CCIE wireless question exams and, on the tech cases and all. And many of the times you discuss it can't be way complex, right? If meaning there has to be a solution to it, unless, in one case we really had to tell them that you will have to go to Apple and get your laptop swapped. We did everything. Me To give you a classic case, we have is a gaming pro. Many of our students are on gaming scholarships because we do have a specialized gaming department in our engineering school. And some of them, they get sponsored by the electronic arts and all those gaming software peoples because they are ranked gamers. So this guy, $7,000 worth of laptop, but he's using a $2 worth of Nick card, which he got from the local box store, and he wouldn't change it. So in the end, we went and spent $50 and gave him a new Nick card. Here, this is what is going to help you out. He just would change it out, and he needed to play the games because that way the people he gets his scholarship money to pay his fees. So, you know, so don't get afraid of the problem. I know it becomes very intimidating. I used to in your when you are green, you do get afraid, but take it as a challenge, you know. And each problem, it is not like you are putting out a fire. You have to analyze the problem and tackle it step by step and go from there. And once you have your checklist and your document and you know it, and then you compare, right, that okay, with this part of the network in the same, who else is experiencing the problem? Is it localized, or it is global, or it is just to particular set of users? And you start your strategy from there.
Right. Thank you so much for sharing all your insights, Hiten. So we are done with all the questions. So if you have anything that you would like to address to the audience on large scale Wi-Fi deployments, please do.
So, meaning, large scale deployments, obviously take your time, do your surveys, understand your audience, understand the requirements, obviously, understand your environment. That is the big thing, because you are disrupting an environment, you are changing the RF. The air is there, the space is there, the sound waves are there, everybody's making a grab on that air which is in the environment, the RF signals. As you know, Wi-Fi is completely free and incumbent and all that. Incumbents get, because they pay for it, so they get more uh, a bigger chunk of the pie, whereas you don't. So you work with that, and once you get a hold of it, and try to, as I make sure your least capable devices are also covered for. Like in a warehouse environment, you would want your scanners with with what, with 24 feet racks and the APs on the top with all that metal in it and all that. So each environment is a different one. So least capable environment, find out your audience, find out what they are planning to do with the network. What are your attenuators? How will the network behave once the building is occupied? Who is there? So all those things come into play, and each step requires a meticulous, and ensure your documentation is right, because whether or not you decide to move to a better job or usually as network engineers we inherit a network. It's not every day you get a greenfield network completely. So leave it for your successor to get it, and it will also help you in the long run. Like, once your upgrade cycle comes in, you are still around. Imagine I have to replace 500 APs. Am I going to sit and again retype the MAC addresses? No, I'll use some kind of an API, pick out the serial numbers and use that, right? We now, with the help of a AI script, I can do all that stuff, which, and Catalyst Center, the workflow is there. I can reuse those host names and I can reuse everything. So if you have your documentation right, and the logical as well as the physical topology matches each other, which you, because the physical topology is with the technicians, they are humans, they make it mistake. I learned it also like that the hard way this week. There were a lot of pleasant surprises than what it was documented, than what was available. But once you make those changes, then make sure you again aggregate those changes to the correct, because it's a database, right? It's not going to go and find out. So you, as a custodian of the new data or a modified data, make sure it gets applied to your tools or to your software or to your documentation. So come again when you have to reuse it, you will have to do it. You know, it's like putting the comments in your line of code. 5 years from now, you would be wondering, what was that variable doing? Now I don't understand. Right? So that helps.
Yeah. Yeah. So that's all for today's episode, everyone. So if you like the episode, please like, share, subscribe, and continue watching Weekly Wi-Fi Wisdom for more episodes on Wi-Fi. Thank you so much, and we'll catch you guys in the next one. Thank you.